Hi there. I hope so all of you are doing well. So today the problem we are going to solve is LeetCode problem number 301, remove minimum invalid parentheses. I've already solved this problem with the first approach, that is backtracking. You can see the link in the description. And now we are going to solve this same problem with the second approach, that is level order traversal. The prerequisite for this is BFS. Our goal is to make the expression valid by removing the minimum number of the parentheses. So our today's problem agenda is, first of all we'll discover what is the problem, then we'll find where does this problem occur in the real life and why should this problem be solved. How to solve this problem actually relates to dry running, and what is the solution is associated with the final code. So first of all, let us take a look at the problem. What is the problem? We will be given a string in which we will have an invalid expression that will contain open and close parentheses along with letters. Some parentheses will be misplaced, that's why that expression will be an invalid expression, like here you can see in the example. Our task is to remove minimum number of the parentheses to make it valid, and at the end we have to return all the possible valid expressions that can be created from the invalid expression. Now let us take some examples to understand this problem again. First of all, this problem is the same as provided at the previous page. Now you guys can see here we have two ways to solve this invalid expression. There are two ways to make this invalid expression into a valid one. First way is to remove first and third index and get a valid expression. Second way is to remove second and third index and get a valid expression. Now take a look at the second example. Here our invalid expression is provided at the left side and the valid expressions that are obtained out of it are provided at the right side. One way is to remove just the first index parenthesis, so that we'll get the solution one that is provided at the top right corner, or you can say top right side, and that's not the corner. The second solution, the second way is to remove the third index and we'll get a second different solution, that is valid expression. Third way is to remove fourth index and we'll get an the same valid expression that we got in the previous method. So you guys can see here, from a single invalid expression, by removing the just different parentheses in different ways, we got two valid expressions out of it. And here you guys can see the total number of the parentheses removed in all these three ways was the same, that is just one parenthesis was removed. Now take a look at the third example. This example has been provided at the LeetCode platform in the editorial tab of this problem. Now our invalid expression is provided at the top, and the yellow background box is representing the bracket that is to be removed. Now here we can get two valid expressions out of the provided invalid expression, but there is again different ways to get each solution. Solution number one can be obtained out of the invalid expression either by removing zeroth and first index, or second and third index, or zeroth and third index. Or there could be other ways also. These are just three ways described here, but there are all other possible ways, like zeroth and second index as well, zeroth and fifth index as well. Uh, and the second solution here is provided can be generated by three other ways. Though I repeat again that there are more other possible ways to get the same solution. First way to create a valid expression out of the invalid expression is to remove zeroth and fifth index bracket. Second way is to remove first and fifth index bracket, and third way is to remove the second and fifth index bracket. Now, these were the examples to just understand the problem. Now, where does this problem occur in the real life? First of all, our code compilers, the interpreters, they are validating the brackets in code. Secondly, the expression parsing in calculators, query interpreters, they also work on the same principle. Form validation, while filling a form, it's also made uh, it's also taken in consideration that the brackets are provided properly. These are not the forms you fill on some platform. These are not the registrations forms or some other things. These are the particular forms. Just Google on it. Where does the bracket problem occur in case of form validation? The fourth one in which this problem occur is the text editor and the IDEs. They help us in syntax checking, and that one is provided at the bottom. You can see at the left side, VS Code is highlighting a bracket with red color, which is showing that this bracket is invalid. It should not be here because it has no opening bracket. It's telling us that our complete expression of the brackets is invalid. While on the other hand, at the right side, you can see VS Code is not providing us any type of error. Now, let us take a look at uh, why this problem should be solved. First of all, we have to understand the invalid parentheses, uh, how to solve these invalid parentheses, how the process is going on at the back, how code interpreters are solving this problem. So understanding invalid parentheses, uh, how they break logical expressions is very important. Secondly, it helps us in error detection and autocorrection. You have seen in editors that whenever you create a open parenthesis, it auto suggests you a close parenthesis, and whenever you create a close parenthesis without an open parenthesis, it will automatically tell you that this is wrong. Secondly, thirdly, it improves robustness in systems handling dynamic or user generated input. And then it's a graph problem. Graph traversal is occurring here. That's why we have to find the shortest paths, the shortest minimum number of the removals, so that we'll get the final best answer, the best valid expression that can be generated out of the provided invalid expression with the minimum removal. And at the end, BFS ensures we find solutions with minimum removals. Now, in the dry running, we'll understand how BFS ensures this thing. Now, how to solve this problem? This is a bit of an algorithm you can think. First of all, we have to use level order traversal, that is BFS, to generate expressions. We'll have first of all an invalid expression. We'll generate the possible expressions out of it. We will start from the original string, that is invalid expression, and remove one parenthesis at a time to form the next level. We will stop at the first level where valid expressions are found. If we get valid expression at any level, we'll stop there. At that level, all the valid expressions are the answer. We will use a queue to process the strings level by level. All the invalid expressions will be added into the queue one by one. We'll use a set to avoid the same string multiple times, and in order to check either this generated expression is valid or not, we will ensure that left count is equal to the right count. This is a bit of an algorithm. After going to actual after covering the actual code, we'll know that what is actually happening. This is another actual pseudocode you can think of. First of all, we'll treat the problem as a shortest path search. Each state is actually representing the invalid expression that is formed by removing some parentheses. We will start from the original string. We will generate all the strings by removing one parenthesis at a time. We will use a queue for level order traversing, and then at each level, if a string is valid, we will stop and return all the valid strings from this level. Otherwise, we will continue to the next level. We will use a set to avoid revisiting again the thing is repeated. Now take a look at the term visiting. This is actually representing the term explore, and you guys know that in graph traversal problems we have to explore the graph. So here we have two ways to solve this problem, BFS and DFS. We have already understood the intuition, so our way of solving this problem is level order. So we are going to use BFS. So now let us take a look at the dry run. So here this is the problem. We are going to perform dry running on it. The conditions for an expression to be valid and invalid are provided at the top right corner. Now let us consider this is the initial expression as a state in our traversal. So first of all, we will take a queue. Since this expression is invalid, we are going to put it into the queue. Now we have different ways. First of all, if we remove the 0th index, we will obtain this. If now we will also put a visited um, set so that we can keep track of the visited states, and also we will take a list of results that will keep track of the results. Now if we remove the first index, we will obtain this, and if we remove the second index, we will obtain this. Now the first as you guys know that we have completely visited the first state, that was the initial string invalid expression. Now here the first expression we obtained by removing the 0th index is invalid. The second expression we obtained by removing the first index is also invalid. But the third expression we obtained by removing the second index is valid. So we will put that into the result list. Now let us take another example. Here this is the invalid expression, the initial string provided to us. Let us take the queue, empty queue, a set of visited in which the visited states will be placed in order to keep track, and the list of the result in which all the valid results will be placed. Now first of all, as you guys can see, this is an invalid expression, so we are going to put it into the queue. If it was a valid, then it would directly be placed into the result list, and this was the final result. Now first of all, if we remove the 0th index, we will get this one, as this is invalid expression, so we have marked it. Now if we remove first index, we will get this. Here this is a valid expression, we will mark it as valid. Now since it is valid, we are going to place it into the list of results. Now if we remove the second index, we will obtain this, and this is invalid. If we remove third index, we will obtain this, and this is valid. So we are going to place it into the list of result. Actually this is not the list, this is the set. Now if we remove fourth index, we will get this, the same thing as we get by removing the third index. This is valid. If we remove the fifth index, we will get this one. This is also an invalid expression. And on removing the sixth index, that is the final index, we will get this one. This is also an invalid expression. So now we have completely visited the provided invalid expression. Since you guys know, we have already made it clear that the level where we get the valid expression will be the last level we have traversed. So we are not going getting into the much depth of this tree. Now this and this, these are the two valid expressions we have obtained out of the previous invalid expression. Now let us take a look at the code. We will use a double-ended queue from the collections that is provided in the Python. So here we have created a valid is valid function which checks either the expression is valid or not. It will just keep track of both the open and the close parentheses. If they are balanced, that means equal number of the closed and equal number of the open parentheses are there in the expression, then that is a valid expression. That's not a rocket science function, that's simple function. Now the main function is remove invalid parentheses. Here first of all we will check if the expression currently we have is valid or not. If it is valid, we are going to return it in the form of list. But if it is not valid, we are going to initialize a list of result, and since we are going to visit this invalid expression, we have put this into a set that is called visited. We are going to initialize our queue. Now the found is made false. Found is actually representing the valid expression level, the level at which we'll obtain the valid answers, valid expressions, because we have to stop at that level. Now while we have any invalid expression within the queue and we have not found any valid expression, we will perform a for loop whose range will be equal to the number of invalid expressions present in the queue. For each invalid expression, we will check either it is valid or not. If it is valid, we will append it into the result and make found true. If found is true, we will continue. That means we are not going to look further into the parenthesis, or we are not going to look further into the expression, because we have found that it is valid. But if it is not valid, that means we have not yet found, and for each character in that invalid expression, if it is not a parenthesis, that means it is a character, we have to continue. But if it is a parenthesis, we are going to take the invalid expression from 0th or the starting index to that particular index, excluding that particular index, because you know the slicing concept here. The next is equal to current, and uh, the left index which is not provided before the colon is actually 0, and the right index, that is I, is excluded. We will exclude that specific index, and by excluding that specific bracket we will obtain a child expression out of the parent or the current invalid expression. If we check either we have visited this expression or not. If we have already visited this expression, then we will just continue to the function. But if we have not yet visited it, now we are going to put it into the queue, and we are going to append it and add it into the visited. And after this complete traversal, at the end we will have result. And that's all for personal practice. This is the problem I have written. You can try on it, or even you can also increase number of the parentheses if you want. And thank you all much. Thanks a lot to all of you for being with me till yet, and do not forget to subscribe.